Composite functions. Find f of g or g of f with functions. What are they? Functions are a relation from a set of inputs to a set of outputs where each input maps to exactly one output. Why? Helps to extrapolate data when patterns emerge. Interesting fact, turtles have a lower shell called a plastron. Now, let's take a look at the definition of composite functions. The composite function of f of g of two functions f and g is f of g of x is equal to f of g of x. The domain of f of g is a set of all x in the domain of g such that g of x is the domain of f. Now, let's see what that means with the example we're going to discuss in today's video. Let's read the steps. Step 1. Substitute the inner function. Step 2. Substitute new input in the outer function. Step 3. Follow order of operations. Now, let's read the question. Find f of g of x and g of f of x, where f of x is equal to 3x minus 1 and g of x is equal to x squared minus 2. Let's write down what we need to find. F of g of x and g of f of x. Let's start with f of g of x. What is the inner function of f of g of x? It is g of x. Now let's substitute x squared minus 2 for g of x into f of g of x. So we have f of x squared minus 2. X squared minus 2 is our new input. What do you think is the next step? We need to substitute x squared minus 2 into f of x. Let's write down f of x, which is 3x minus 1. Now we can substitute our new input into the variable. So now we have f of g of x is equal to 3 times the quantity of x squared minus 2 minus 1. Let's distribute that 3 to both terms in the parentheses. So we have 3x squared minus 6 minus 1. And minus 6 minus 1 is minus 7. So f of g of x is equal to 3x squared minus 7. Now let's find g of f of x. What is the inner function of g of f of x? It is f of x. Now let's substitute 3x minus 1 for f of x into g of f of x. So we have g of 3x minus 1. 3x minus 1 is our new input. What do you think the next step is? We need to substitute 3x minus 1 into g of x. Let's write down g of x, which is x squared minus 2. Now we can substitute our new input into the variable. So now we have g of f of x is equal to the quantity of 3x minus 1 squared minus 2. Since we have two of the same binomial, let's go ahead and write it out twice. So we have the quantity of 3x minus 1 times the quantity of 3x minus 1 minus 2. Let's multiply the binomials together. So we have 9x squared minus 3x plus 1 minus 2. Let's combine like terms. Minus 3x is minus 6x. 1 minus 2 is minus 1. So we have g of f of x is equal to 9x squared minus 6x minus 1. Now let's verify f of g of x. We need to substitute any real number into g, then f, and compare the value to f of g. Usually, you want to choose a small number, but be careful with 0. That number is tricky. We chose negative 2 because negative numbers are awesome. So let's substitute negative 2 into g of x. So now we have g of negative 2 is equal to negative 2 squared minus 2. Negative 2 squared is 4, and 4 minus 2 is 2. So g of negative 2 is 2. And that is our new input. So we need to substitute 2 into f of x. So now we have f of 2 is equal to 3 times 2 minus 1. And 3 times 2 is 6, and 6 minus 1 is 5. So f of 2 is 5. That is the output value we want when we substitute negative 2 into f of g of x. So let's substitute negative 2 into f of g of x. So now we have f of g of negative 2 is equal to 3 times negative 2 squared minus 7. And negative 2 squared is 4, and 3 times 4 is 12, and 12 minus 7 is 5. So we have f of g of negative 2 is equal to 5. The output values are the same, which is what we want. Otherwise, there would have been a mistake somewhere. Now, let's verify g of f of x. Once again, we need to substitute any real number, but this time we start with f, then g, and compare the value to g of f. Usually, you want to choose a small number, but be careful with 0. That number is still tricky. We kept negative 2 because it worked last time, and because negative numbers are awesome. So let's substitute negative 2 into f of x. So now we have f of negative 2 is equal to 3 times negative 2 minus 1. And 3 times negative 2 is negative 6, and negative 6 minus 1 is negative 7. So f of negative 2 is equal to negative 7. And that is our new input. So we need to substitute negative 7 into g of x. So now we have g of negative 7 is equal to negative 7 squared minus 2. And negative 7 squared is 49. And 49 minus 2 is 47. So g of negative 7 is equal to 47. That is the output value we want when we substitute negative 2 into g of f of x. So let's substitute negative 2 into g of f of x. So now we have g of f of negative 2 is equal to 9 times negative 2 squared minus 6 times negative 2 minus 1. Let's simplify. Negative 2 squared is 4, and minus 6 times negative 2 is positive 12. And 9 times 4 is 36, and 36 plus 12 minus 1 is 47. So g of f of negative 2 is 47. The output values are the same, which is what we want. Otherwise, there would have been a mistake somewhere. Now it is your turn, so go ahead and pause the video here so you can take your time to answer this question, and I'll show you the results in 3, 2, and 1. Here's f of g of x, and g of f of x. Here we verified f of g of x. Here we verified g of f of x. Did you get it correct? Fantastic. If not, there's always tomorrow.